So we shall start. What is this? I'll reconnect. I will update all the files. Not apparent, not yet updated. Hmm. Updated. So today, like yesterday, we discussed about L1 and L2 regularization, if you remember. Today, we are just going to complete the coding part and proceed. I will run all. Obviously, there will be errors. Hmm. What is the error? No error. Everything ran. Hmm. So from like today, we are going to implement both lasso and the rigid regression. Okay. Now we'll proceed. What have we done? Start in the beginning is okay, guys. How do you want to go through? Tell me. You want me to explain the code, or you guys want to go through the code first, try to give an explanation, and then you want me to cover if there is anything missing? What do you want? You want me to give the explanation, or you want to try one? Anyone up for it? Okay, no one, no problem. So here, what we are doing all the imports, right? So nothing much here. After that, we have a data set called headers.csv. So what do we have in headers.csv? You can go ahead and see the documentation. So this is nothing but a data set where we are trying to predict a baseball player's salary based on various statistics associated with the performance in the previous year. So whatever he has performed in the previous year, based on that, what will be the salary of the player this year? We are going to find out. Okay. So what are the columns we have? We have the name, at bat, hits, home run, runs, RBI, RBI walks. Although I'm not very aware about baseball, so and then most of you would not be aware much about baseball, right? So let's see how we can proceed using this data set or such data sets where we don't have much idea, right? Then in those cases also, we will need to do the analysis, build the model and all, right? How to do it? Let's proceed. So these are the columns which we are seeing using df.columns code. When we do df.info, um, these are the columns that we see. Obviously, we have something called name. So since this column, its column name is unnamed, but no, it's not unnamed. Here name is present, right? So what we are doing is, since we are going to build a model, new league salary, here is a salary. Since we are going to build a model, obviously we will need the names later, right? So for now, while we want to work with the data set, work with Python, what we are doing is we are removing the name column. Okay. Later, what we can do is better it is df copy equals to, what I will do is I will save a copy of it. Okay. Now, so I'm saving a copy, and from the original data frame, what I'm doing is I am removing the column name column. Okay. So like this. Now, after that, what we are doing when we do df.info, we see that there are 322 columns where all are having non-null values, out of which few the data types are combination of integer, object, and float, right? Uh, are there any missing values? Yeah, I see some missing values. So salary is having, yes, sorry. Thanks for letting that know. I missed it. So salary is only having 263. So what can we do? Total 59 columns in the salary, sorry, 59 rows in the salary column has missing values. So let me know, give it a think. What can we do? Is it a good idea to drop it, or it is a good idea, or what is a good idea to replace it? So in the meantime, you are thinking we will do some um, encoding. Okay. So we will use one hot encoding for feature variables, or the categorical variables, right? We will create dummy. What are we doing, guys? See, we are creating dummies for the league column, division column, and new league column. Okay. I think Vagesh, it's the target value, so we can drop it. What I suggest is, see, I will tell you a unique way. You will like it. Guys, if you consider 80-20 rule, right? 80-20. What do you think? 20% of 322 would be 20% of 322 would be 64. Agree? How many rows are missing? 59. So what can we do is, since the salary values are missing, let it be like that only. We will use those rows as test data. Can we? Yeah. So fine, we don't have the value, no problem. We'll use it as test data. We will use the model itself to predict. And we can use the other columns to train it. Obviously, we will be using cross-validation and everything, so it won't be a problem. We can't validate, right? I agree, we cannot validate. But you tell me, if we replace it, right? If we replace it with mean or median, then also there is no option to validate, right? Right? So what we can do is we can calculate the mean median separately and see, like for these 60 values, what is it that is coming. So instead of getting all the same values for this 59 rows, it's better now that we are getting different values, and then we can also like see what is the variance uh, between the mean and these predicted value. Okay. Now, since we have these league, division, and new league as categorical values, what we are doing is we are first converting the dummies. Uh, so it will always be 0 1 0 1 like this, right? Generally, the dummies are the dummies are Boolean value. So we need to convert it to integer, right? Like 1 or 0. So here dummies dot as type int is actually converting it to 0 1 value. Okay. Prasant is asking, can we split data into test and train based on condition, or it is used to auto split? So if we don't mention any condition, it will auto split. But if like for the values, right? For the values where salary is blank, we can extract those rows, and for those rows, it will be our test data, right? We can do that. And all the other rows will be our train data. So there we cannot go ahead and use the function from train test split. We have to do it manually. Okay, Prashant? Please write it as an assignment. This is something that you guys will need to do. Please write it as an assignment. Okay. If you see you are not able to do it, you can take help from ChatGPT, whatever it is, but I want you guys to do that. Okay. Hold on, guys, one second. Okay. We keep these days. Siddharth, not able to understand. We keep these days. What is this? Oh, yeah. Sorry, sorry. I have got to like chance to use DeepSeek. Till now, it's giving me good results. Yeah, yeah, and it's way cheaper than ChatGPT Pro version. I'm loving it. Have you guys, have you guys taken a Pro version of DeepSeek? Yes or no? I recommend you guys take it. It's very cheap. I tried Olama. Try DeepSeek once. You will love it. Okay. These days, all of us use these chatbots, right? Be ChatGPT, DeepSeek, a lot of the Beta Copilot, everything. So from the yes, yes, yes. So from the both economy and the output point of view, I really recommend DeepSeek. Obviously, DeepSeek is not gonna give me promotional benefits, but yeah, that's the truth. Okay, so guys, what is happening here? Whatever is the when India model will come, they are preparing. No, um, I got some announcement that they are preparing and all. It is we built it. No, no, it's still in progress. They have built it. Once our course is done, we will build. See, generic testing, like generic data is available. We can do it, no problem. What's important is how you are doing the transfer learning. That's the most important thing. If you can do it, obviously anyone can build these chatbots these days because all that matters is data. Mhm. Now, so this is league column. If you see, so what are the values? Different values for league, league A, league N. Similarly for division, what are the two different values for division? Division E, division W, and what are the values for new league, new league A, and new league N? So these were the two possible values, A, N, E, W, A, N like this. So here what's happening, while doing one hot encoding, we are creating new columns, right? So these are my new columns, which looks like this, obviously 0 1 0 1 0 1. Okay. Now, till this point, it's understandable, guys. Everyone is clear till this point. Now we are going to the business angle. It will get more tricky now. Okay. Think the area where uh, there is higher potential is quantum computing plus AI. Quantum computing is the next big thing. I agree. You know the like we can also discuss the basics of quantum computing after this class. Like generally, whatever we are studying now, either it's a zero or a one, right? Either it's true or false. But in quantum, yeah, qubit, exactly. Yeah, yeah, we will. But in quantum computing, what happens is apart from zero and one, other values can coexist. Coexist is the main thing. It can be zero and one at the same time. It can coexist, right? So that's a great thing about quantum computing. So, oh yeah, sure, sure, sure. So generally in our system that we are seeing, what do we have? A number is like a particular bit can be either zero or either one, right? Either or one. It cannot be both at the same time. But in quantum computing, the basic is both can coexist together. So as a result of this, what happens? Using a normal supercomputer, a calculation which will take 9,000 years can be done in a second or a minute using quantum computing. Just imagine. I can't explain you that right now. Um, the theory, if you want to understand, we will do it separately. But that's how it is prepared, such that, right? So yeah, it's a great thing. Right. The total entire concept is different here. Okay, so let's proceed. What are we doing is creating a label X and Y. So what is the Y label? Y label is salary. So now from this salary, we will have to take Y train separately, if you remember. And after that, What we are doing is we are dropping salary, league, division, and new league from this to get all the numerical columns. Okay, only numerical columns. Obviously, these are now numerical columns uh, after doing the one hot encoding, but these are having different names now. So league A, league N. So we can remove or drop the league column because new columns are created with one hot encoding. Similarly, division and new league columns also we remove. Okay, axis is 1 and s type equals to float 64. So the numerical that we are like creating for the all the other columns, the numerical values, the df type as type, we are converting it to float 64, right? Now we are getting all the columns in a list. So these are all the columns, okay? The numerical columns. Now what we are doing is concatenate the dummy variable data frame and x numerical to create x, right? So if you see what were the dummy variable data frame, the dummy variable data frame were these dummies for league and division W and league and all these, right? What are we doing here? If someone is able to tell me what are we doing here, a dairy milk from my end. Guys, anyone? What are we doing here? Anyone? This highlighted line of code, what are we doing exactly? This is a dairy milk question. No, 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 no. Not only kind of creating new data, not this, something more, something more, something more. You have to see it. Why are we doing this? Why are we doing this, guys? We already did this, right? We already have a dummies data frame. So why we are not adding the entire dummies data frame here? Why only these columns? Why? You got my question? Guys, any comments? Target is based on these columns. No, 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 no. Sina is right. Reduce multicollinearity. If you remember, we discussed last day one thing that if we are having two columns for league A and league N, if we drop one, we can still figure out the values using the other column, right? For example, the league N here is 0. It means the value where it is true or 1 is the other option or the other column which is not present, right? So here we are selecting or dropping basically one column each from league, division, and new league. One column each we are dropping. Okay. So see, only 3 columns are there instead of 6. You got it? And why we are doing it? To reduce multicollinearity. Got it, guys? Is it clear? Guys, awesome. Now, this is our entire X, which consists of all numerical columns, right? Now, for now, we are doing a split, train test split. But guys, remember, please remember that your assignment is to take the Y test and X test from those data points only where the salary is missing. So Y test will be from only from the point where it is missing. So Y test we don't have at all. X test will only be there, which we will use to predict. Okay. So this one you guys need to do. Now, lasso regression performs best when all numerical features are centered around 0 and have a variance of the same order. If a feature has a variance that is orders of magnitude than others, it might dominate the objective function and make an estimator unable to learn from the other features correctly as expected. This means it is important to standardize our features. We do this by subtracting the mean from our observations and then dividing the difference by the standard deviation. This is nothing but the standard scalar that we do, right? If you remember, when we are doing standard scalar, what does standard scalar do, guys? If you remember, it is having a mean of 0 and a standard deviation of 1. So the range is -1 to +1 for one standard deviation, if you remember, right? Standard scalar, we do this. Why we do this? Because Lasso performs great on the data which is scaled using, let's say, standard scalar. Why? Because standard scalar, the mean is around 0, right? And obviously the standard deviation of 1 is present. This one we have already done it, so I'm not going deep into this. So what we do is we fit the X train for numerical values, and obviously we transform it. So here, same thing we are doing. We are fitting it and we are transforming it, right? So we are fitting using the X train and we transform both X train and X test data. X test for which? For what? For the numerical data only. Okay. Apart from this, one more use case of doing standard scalar is all the columns are having values in different scales, right? The unit is different. So in order to be able to do a apple to apple comparison, we do this, right? So that every column is now present in the same scale. Now, here what we are doing, guys, if you see, for now, what we are doing is in the Y train and Y test, wherever it is NA, we are filling it with median salary. But we will not do this. Okay. What we will do is we will predict those. Okay, guys. Now, while creating a lasso model, what is that? First, we apply a lasso regression on the training set with regularization parameter alpha equals to 1. Alpha equals to 1 means highest penalty. Okay. So if the overfitting is very high, it means we penalize everything and very, very much. So alpha equals to 1 means highest penalty. So this value is commonly used as default and provides good balance between maintaining model complexity and reducing overfitting. Why? No, no, no. It's not the case. We are just learning how to use lasso. Don't worry. Prashant, we are learning how to use lasso. That's it. Yeah. Now, how to do it or when to do it, we will learn in every scenario, right? All the other algorithm, machine learning algorithms that we do, there will be a scope to see if it is overfit, then implement a lasso or rigid regression model, right? But first we need to learn it. That's why. So for the lasso model, by default, we use alpha equals to 1. The max iteration that we are doing is 1000, let's say, and we are fitting the X train and X test, right? Using this, we will receive a intercept and the coefficients. So what this coefficient is, guys, if you see, if you see that I will share my iPad for this. What is the max iteration parameter? You tell me. Can you try? Can you try? Just take a wild guess, not an issue. Take a try. We are telling the model how many times to run the back propagation. Uh, Back propagation is too much. Okay, so it says maximum. You understand? You don't understand the gradient descent. Now, let me tell you. In order to arrive at a optimal solution, okay, let's say, guys, we do not know gradient descent as of now. Okay, so don't worry if you. I will take a new sheet. Hmm. Consider that this is my. Uh-oh. This is the point as the number of iterations for the regression. Yeah, that is correct. Suppose this is the point where you need to go. Now, uh, you start from here. Okay, you are taking big steps. There is a chance that if you are taking big step, you might miss the actual point. So what will you do? In that case, you will take small steps. You will take small steps. But if you are taking small steps to do the learning, to do what? In that case, it will take you forever to learn, right? If you do like this, it will take you forever to learn. But in the end, you will be able to reach the exact point where your output is, right? So instead of doing this, here what will happen? Here it will be fast learning, but not efficient. Here it will be efficient but very slow. So a solution to this is gradient descent. Solution to this is what, guys? Gradient descent. Now, in case of a gradient descent, what happens is we start the learning taking big steps, big steps, big steps, right? But as the gradient reduces, so here if you see slope, gradient means slope. So here like this, it means slope is high. But as this curve is coming, this curve, right? So here it is almost going towards a flat line. At this point, the slope is zero. At this point, the slope is very high, right? So as the slope reduces or as the slope decreases, the learning rate also decreases. And when the slope is minimum or zero, the learning rate is minimum. And again, as the slope increases, the learning rate increases. So as a result, by adjusting the learning rate, we are able to attain a perfect model. Okay. Why? Because it knows where and it is so efficient that it knows where to learn fast and where to take it slow. Okay. So this process is known as, how are we coming down? How are we coming down? We are dependent on gradient while we come down, right? While we descend. So that's why this process is known as gradient descent. Now, in order to be able to come from the starting point to the output point, the max number of iterations or max number of learning you can take is 1,000, not more than that. So within 1,000, you have to do this. Else, if the, as I mentioned, right, that if this would be 1 lakh, then what will happen? It will take forever to learn. The time consumed will be very high. Now you got it. What is max iteration, guys? Everyone got it? Guys, what's max iteration? Everyone got it? Is the confusion? Hey guys, please respond. Everyone, what about others? Hmm. Please be responsive. No, it really helps to keep things fast. Okay. Now, one more thing I wanted to show you. We can say that gradient descent is a variation of parameters with respect to predicted output. And when we try to iterate a lot, so the difference is less where I've tried. Is there any relation between max iteration and gradient there? No, there is no relation. There is no relation. The maximum number of iterations, we are prefixing it such that whatever you need to do it within this. So it will accordingly make its plan, right? For example, if you know that you are going to play a test match, what will you do? You will start slowly, you will play slowly and all until unless you are, let's say, Rishabh Pant or Virendra Sehwag, you will play aram se, right? But if it's a T20 match, what will you do? You know the number of balls allocated are less, so you will dhoom dhadaka starting say, right? So here also it's the same case. Now, guys, if you remember lasso regression, how it was, y equals to beta 0 like this, right? So depending upon this, if you remember in lasso regression, what was the case? Sum of the beta coefficient will be 0. Why 0? Because there was something called lambda, which was penalizing the coefficients, right? And as a result, some of the coefficients will become 0, right? So how would this look like? It would look like this somehow, that let's say this one becomes 0 and this one becomes 0, right? So here, are you able to see there were multiple columns, right? Hey, where is my mouse? Okay. So there were multiple columns in the X variable. So here we are taking all of them, right? You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, more than that, right? So those features or those columns which are not relevant or not contributing to the output, what we are doing here, we are marking the coefficient as 0. So now what will happen? These will not at all contribute. So in this way, it will reduce overfitting. Okay. So this is also one way to find if it is overfit or not. Why? Because if it was not overfit, then it would have not done this 0 thing, right? You understand, guys? So what is the lasso intercept? The intercept is 552, and these are the coefficient values where it starts from. This is my intercept, and this is for, let's say, x1, x2, x3, x4, x5 is 0, and so on, right? A positive coefficient indicates that as the independent variable increases, the dependent variable also increases. For example, here, this coefficient is negative. It means with increase in this coefficient, the highlighted one, the salary will decrease, right? If the coefficient is positive, it means what? With increase in that particular coefficient, salary will increase. What is the meaning of zero intercept or negative intercept? The lasso intercept you are able to see here, right? What does it mean? Anyone would like to take a try? What this lasso intercept of 552 means, guys? Line intercept, but what is the meaning of it? Value of y when x equals to 0. Perfect, guys. And now, this is the training and testing data model evaluation. I'm not going here. This is something that you can also do. Now, to better understand the role of alpha, that is regularization parameter, plot the lasso coefficient as a function of alpha. Okay. So what we are doing is we are basically plotting all these coefficient. We are basically plotting, where is it? we are plotting the lasso coefficients as a function of alpha. Now what we are doing is, for alpha values, uh, where is it? We are taking from, for alpha, we are taking the values from, let's say, 10 to the power minus 2 to 10 to the power 2. Okay. So if you see this, 0.01, it means 10 to the power minus 2 to 5 into 10 to the power 2, like this, right? So from minus 10 to the power 2 to, let's say, 5 into 10 to the power 2. And how many points I am asking for? I am asking for 100 points. So I will have how many alphas present here? Quite a few. Obviously 100 alphas, right? Now, we are also taking a lasso iteration, like lasso regularization model with max iteration set as 10,000. Then what are the coefficient? The coefficients is blanked out. What we are doing is, for A in alpha, right? So here we are taking the line space starting from 0.01 till 500. We are taking 100 values equidistant from each other, right? And here the coefficient is blank, intercept is blank, everything. What we are doing, we are setting the params here. For A in alpha, we are setting the param as alpha equals to A, then fit it, and then append the coefficient, right? And once it is done, what are we doing? We are basically plotting all the coefficients with alpha. So here, what does it mean, guys? If you see, as the alpha value increases, the coefficients are coming to, like, where are they coming? The coefficients are coming to 0. It means as the value of alpha increases, the penalty is getting higher and higher. Yes, 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 beta 1. You see different colors. All these colors are beta 1, beta 2, beta 3, beta 4, like that, right? And here, this is the alpha value. Now, what is alpha? Alpha is nothing but uh, penalizing penalty parameter, or whatever you say, right? So as the penalty is increasing, what is happening? The coefficients are moving towards 0. So if you see, if the coefficient, if the alpha value is greater than 100, the penalty is so high that almost all the coefficients are becoming 0, right? And by the time it reaches alpha equals to 1, some of the coefficients are 0, some are still having some value, right? So this basically shows how the coefficients vary with the value of alpha, right? What do you see? When the penalty parameter alpha is less, right? Small. So these coefficients are like just roaming around, right? Such huge coefficient values. Something is plus, something is minus, so huge. But as the penalty increases, what's happening? If you remember last day, as the penalty increases, or heavier penalty is indulged, the value of the coefficients keep going towards 0, and eventually it goes 0 for some, if you remember, right? So that's the reason here what's happening is, as the value of alpha increases, the lasso coefficients, that is beta 1, beta, like beta I, whatever it is, right? It is going towards 0. And yes, Sheena, we usually by default take alpha equals to 1. Okay. Because if we take more than 1, like 10, 100, it's like forcing the parameters to become 0. It's not balanced thing. Okay. Guys, you're liking it till now? So whatever I understood, like, helped you understand it, it's the same thing that's written. And here we are creating a lasso on CV. Okay. So this one I will leave it to you for exploring. Same thing, we have studied CV, we have studied lasso as well. So it's no point spending more time here. So I will leave it to you to explore. So one thing I would like to tell you, this particular seat has a lot of things, right? We won't be able to cover all. So it's something that we will cover the most important ones. The other ones that you can do self-read, we will leave it, and then you can take a look at it. If you feel any problem or any issue, you can obviously get back and ask and clear your doubts. Okay. So this is how we are going to move forward. This one, like, you guys can go ahead. And so here what we are doing is uh, using cross validation, we are finding the best value of alpha. So here the best value of alpha, where is it? Yeah, lasso tuned. So in here we are not, see, we didn't provide alpha value. We didn't. So here we just give lasso CV model alpha, which is this. So here I am giving multiple values, random values for alpha from 0 to 1000, right? Between 0 to 1000, I'm taking 100 alpha values, which I am giving it to cross validation. And it is doing what? Tenfold cross validation, right? With maximum iteration of 1000. So within that, it will find itself the best value of alpha, and then it will execute it and then proceed to see what's happening, right? So this one you understood, right? What great things can we do using uh, lasso regression plus cross validation? Everyone, okay, Vijay, I will re-explain. Mm, okay, let's do this. Where is this? Where is this? This one, Vijay, the one that you were able to see right now. You want to understand this? Mm, yeah, sure. So here alphas is I am taking multiple values of alphas. It means between 0 to 5, sorry, 0.01 to 500, I want 100 equidistant points. Okay. What is second one? Coefficient dot append lasso coefficient under the loop. So here for all the 100 values of alpha, what we are doing, we are iterating using a loop, for loop. And then for all the 100 values, we are executing these 3 lines of code, right? So this model that you are able to see, right? Lasso.set params as alpha. So here in this line, what we are doing is we are setting the value for alpha. That the first value would be 0.01, next value would be x, y, z, whatever. Then the last value would be, let's say, 500. So for each iteration, we are setting the value for alpha here and then fitting the model. Now, once the model is prepared, we will have a coefficient and the intercept of a regression. Yes. Why append? I will tell you. Suppose for each alpha, we will have different coefficients. Yes or no? Better let me print it for you. Could not convert to float one H. Why? What is the problem? Hmm. You are seeing these are all the coefficients for alpha. So this is the for first alpha value. These are all the coefficient beta 1, beta 2, beta 3, whatever it is, right? This is for the second one. This is for the third one. This is for the fourth one. So like this, we have 100 such coefficients. Vijay, got it? Hmm. And then, so for each alpha, we will have a coefficient. That's what we are plotting. And here we are nothing, but we are creating a coordinate. Okay. Plot.gca, it basically creates a coordinate. If you see here, oh God. So this is a coordinate that is being created, XY coordinate, right? That's it. And for each, where is it? As you see, right? Now to everything, as the value increases of our alpha, all these coordinates are going to zero. All these coefficients are going to zero, right? So suppose, let's take the first value. How to read this? What is the first value? Minus 3.02. This is the first value. Here, what is the second value? So minus 3.06, sorry, minus 3.06 into 10 to the power 2 means minus 306 for the first coefficient. What is the, let's say this is for alpha minus 0.01. Same, this is the coefficient for alpha next value. Again, this is for alpha next value. So in third value for alpha itself, it becomes close to minus, like close to zero. And then after that, every value is zero only. You can see. So as we are moving, let's say that first value is close to close to 300 is this one only. Let's say this blue. So this is for alpha equals to 1. Suppose this blue line is a line for coefficient beta 0. Okay, just imagine. So this point for beta 0 is for alpha equals to 10 to the power minus 2. This point for beta 0 is for alpha 10 to the power minus 1. This point is for alpha 10 to the power 0, and so on. So as it reaches alpha 10, right, 10 to the power 1 means 10 alpha, it becomes 0, beta 0 coefficient. Got it? So likewise, these all different colored lines are coefficient. And this line indicates a relation between the coefficient value, how it decreases with increase in alpha. Got it now, Vijay? Yes. Yeah. Obviously. Yeah. Keep asking. No, if you think that you have not understood, just ask. See, like I know how much to explain you, but it's a possibility that I might miss something, or you might need, like you might seek to know more, right? So 100%, just ask me. Okay, here we are training. Okay, so like now, have we defined k-fold? We just gave CB equals to 10. So here we just gave CB to 10. That's the k-fold. No, CB cross validation equals to 10 means what? By default, like it's a hard-coded value we are giving 10. Okay, you got it, Prashant? So here, like instead of using KF, we are directly saying that do this 10 times. You got it? We are doing hard-coded. Yesterday, what we were doing? We were wrapping it in k-fold and giving it to cross validation. Today, instead of wrapping it, I'm just saying, okay, cross validation, do it 10 times. That's it. Not necessary. Not necessary. You can do it. Not necessary. Like not mandatory, I would say. Obviously, it's necessary. Like we are doing something else, so our focus is something else. So the goal is to uncomplicate as many things. Okay. So guys, you tell me now. Everything is same here. Everything is same. Like in ridge regression, I'm not covering it. Only difference is instead of all the parameters becoming zero, these parameters instead of becoming zero, they will go close to zero. That's the only difference. Okay. Rest everything is same as lasso regression. So will you guys do it on your own? Will you review it on your own, guys? We have already covered the theory part and we covered the practical implementation for one, which is same 100%, like 99.9% same. The 1%, 0.1% difference that is there, I told you. So will you be able to review it on your own? Yes or no, guys? Give me a quick yes. Yeah. Trust me, it's super easy. Now, so guys, what did we do? We did cross validation to tackle overfitting. You agree, right? But even after tackling overfitting, suppose we have received a model that is like now perfectly fit. It's not overfitted, but somehow it is not giving better results. Then what can be the problem? Right? The problem can be maybe we are not using the best parameters. Right? Maybe we are not using the best parameters. Obviously, we have grid search CV. So we do validate it, run it multiple times to get the best params, best coefficient. We have regularization, which also helps us neutralize or nullify the overfitting effect by penalizing the coefficient. We have everything. We will learn one more thing in model optimization, that is hyperparameter tuning. Guys, this is a known thing that we have done already. Okay, we will just study it in the theoretical part. Like we will study its theoretical significance as well. This is nothing new for us. So hyperparameter tuning is the process of finding the best settings for the parameters in a machine learning model. Okay. Now the difference between cross validation and hyperparameter tuning is in cross validation, the best parameters are found while learning or while training the model. On the fly, we go ahead and we are able to calculate, measure whatever it is the yeah. So in cross validation, it's calculated on the fly. And in hyperparameter tuning, what's the case? It is set before the training process begins. Hyperparameter tuning involves trying different combinations of hyperparameters and evaluating the model's performance using validation techniques. Okay. So multiple combinations we can try. Now there are few techniques in hyperparameter tuning. Two of them are grid search and random search. Okay. Now there is a very thin line. Hyperparameters doesn't, what is this? Efficient hyperparameter does not involve, involve we have written. Mm, no, it does not involve coefficients. Coefficient wala story, it's only in L1 and L2 regularization. Right. Yes, yes, yes. Now, how it works, let's that we tune. Yes. It's the tuning of the parameter, how much we need, right? Uh, Now, grid search, how it works? Define a parameter grid, specify a set of hyperparameters and their possible values. So for each parameter, what we give is we give a range. Okay. We give a range that this can be your range. Now you need to find the best possible match for yourself, right? So let's say hyperparameters are nothing but all the feature variables. Okay. So give the feature variables and their possible values within which we need to tune it. Now there is something called combination evaluation. The algorithm evaluates all possible combinations of these hyperparameters. Obviously, like if I'm giving 10 hyperparameters or feature variables, it will evaluate all by combining, by doing mix and match and see which works for us, right? Then model training. For each combination, the model is trained and evaluated using cross validation, right? You have seen that cross validation. And optimal parameters, how do we find? The combination yielding the best performance or highest accuracy is chosen as the optimal set. So here everything is cross validation, like grid search or random search, everything works on cross validation only. What is the extra part? The extra part is we select few variables and we define a range for them. Okay, these is going to be your value range. And now once we do that, we give it to cross validation. Hey, cross validation, take it and do my work. So using cross validation, what will happen? We'll be able to find the best possible values for those parameters. And accordingly, we can do predictions, we can find cross validation score, whatever we want. We finding the best range of these. No, no, not the best range, the best value. We give a range and we find the best suitable value for that particular parameter using cross validation. So like this, not only one parameter are there, it can be 5 or 6 or 10 parameters. For all the parameters, we like previously at the start, we give a range and then using cross validation, we try to find the best fit. Okay. Best possible fit or best possible value. Got it, guys? Please repeat grid search again. Okay. I will. I will. I will directly show you it in code. Random search, then I'm leaving it for now. I will directly show you how grid search works from the coding, and then we'll go to random search. Okay, Prashant? That works. It will be easy for us to understand how grid search works from code. So what we are doing is we are getting grid search, and here in grid search CV, where are we using grid search CVC? We are creating. Where is my CV? Yeah, CV. So first of all, CV k-fold or repeated k-fold, same thing. Repeated k-fold is nothing but do it with replacement. Okay. K-fold with replacement or shuffle. So here we are taking n splits equal to 10, n repeats equals to 3, random state, whatever you want to take, no problem. And then grid, what we are doing is define a grid of hyperparameters to search. So here the grid is nothing but 10 values of alpha. Okay, here we are taking 10 values of alpha from the range 0 to 1. So the thing that we did in cross validation using grid search also, we are just doing one extra thing. What is that? Take a range. What is the range? The range is 0 to 1. And how many values I want? I want a separation of 0.1. So what would be the values? The values would be 0, 0.1. Since the separation is 0.1, next value would be 0.2, next value 0.3, dot, 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 1, like this. So I am giving a grid. The parameter, what is the parameter name? Parameter name is alpha, and the range I am giving is this. That's it, right? But this one, we already used, right? We already did in cross validation, if you remember. But grid search is also the same. Okay, it performs the same as cross validation does. Just that we need to give a range to it and the parameter. So this is the parameter and this is the range. We have the model. The model is nothing but either it will be lasso regression or ridge regression. So here it's ridge regression. So what is the significance of ridge regression, guys? Simple, Shah. Exactly. Grid search is this only for a range of alpha. Here we are defining the range. That's it. Okay. So now, obviously, this is model, this is grid scoring. I will take as mean absolute error. Cross validation also I give. The number of split is 10. And that's it. So it will do the search, right? Search is nothing but the model. Here, instead of search, I could have written model also. Decide, no, you give the range 0 to 10, 0 to 100, 0 to 1000, no problem. But since we know that 0 to 1, 1 is the default range. So let's decide between 0 to 1, or let's say 0 to 10, no problem. Then just that you will lead to, uh, yeah, then you will need more time for the training. That's it. Okay, Prasant. We already studied, right, that the default value for alpha is 1. So that's why we are doing 0 to 1. I know you're concerned, like what, how we are getting it and all. But yeah, this is industry standard. Okay, Prashant? Got it? Perfect. So now, same thing, grid search CV. We get this model, then we do a fit, right? This model we do a fit on whole data. The same thing we did in cross validation also. And then after doing the fit, we get the best score and the best params. So best score is minus 238.285 and the best alpha is 0.9. So using grid scores, what do we get? We using grid search, we don't get the prediction or something. We get the best value for the sorry, we not only get the prediction, but we also get the best values for the hyperparameter. So here, what is the best params for the hyperparameter alpha? It is 0.9. So for alpha equals to 0.9, it is giving me a perfect fit model, neither overfit nor underfit, a perfect hyper-tuned model it is giving me. Okay, we got it. And the same model, if you see, where is my model? Where is my model? So this is the search model that we did. Now, what we are doing is we got using results.best param.get alpha. This line of code will return what? It will return 0.9. So we are saying that ridge regression with alpha equals to 0.9. Using this, I am fitting the X train and the Y train. And using this model that is fit with alpha equals to 0.9, we do a prediction. And then after this prediction, we try to find the error, right? Mean squared error or mean absolute error, whatever you want, between Y test and Y predicted. So this is the value that we are getting. It's here it was the best parameter, if you remember, right? This is mean absolute error, and this is mean squared error. So obviously, if you see, mm, this was done on trained data, right? This was done on trained data. This is done on test data. So things will be a bit different. Okay. R score, R2 square or R squared score also you can calculate, no problem. So, yeah, sorry. Understood, guys? Is it clear? Is it clear? It was a marathon slide, a very big slide, and I took it very slowly, right? So that you guys can understand each and everything. But tell me, at the end, you understood everything, right? Everyone, please give me a confirmation. Any questions here? After this, whatever is left, it's a self-read or an additional something. It's nothing about data science. It's about how to create a pipeline and all. So you can go through it. Like this, just a theory, simple thing. Why I'm not covering this is like this is a normal read thing. Okay, you can go through it and ask if you have any questions. Like same thing. Like it's nothing that we have not already studied and all. You can just go through it and ask questions if you have any. Guys, tell me, whatever we covered till now, is it clear? Absolutely clear, yes or no? Any questions, please go ahead and ask. Guys, please confirm. Am I audible? Guys, please confirm. Is it clear or not? Just write a yes or no. So we have L1 and L2 model. We do both or based on the data set, we can decide. You can do any, no problem. Um, like what based on not based on the data set obviously, but if you have some domain knowledge you will know which one to use L1 if you believe that only a few parameters contribute to the result set or the target value. Use L2 if you believe that all the parameters are like almost all the parameters are contributing to the target variable. Okay. Vijay is asking random grid, random search is left. Sorry, let me complete that. Random grid and hypertuning not understood clearly, maybe not able to connect and need application. Okay. Grid search is nothing but acha, cross validation. You understood, Vijay? Yes or no? Vijay? Okay. Just add one thing in cross validation. What is that? I give you a hyperparameter or I give you a feature variable. Okay. And I tell you the range for it. Let's say 1 to 10, 1 to 100, whatever it is. And then, and then I ask you to do cross validation in that range. Usually during cross validation, we don't give a range and also, right? We just do k-fold times and all. Here, we are just giving it a range. We are giving it a boundary. You need to search within that boundary. Got it? So grid search is nothing but a cross validation technique where we add hyperparameter and provide it a range. What grid search does is it finds the best fit or the best value for that hyperparameter. That's it. That's one line addition. Add a hyperparameter, number one, give it a range, number two, and the cross validation will find the best value in that range. That's it. Done. Okay, Vijay? Vijay? Cross validation we do with set of feature like k-fold. Here, why we are doing feature tuning. Rephrase the question, please. Please. Why to set range for features? Um, so that we can find the best value, right? If we don't give it a range, it won't be able to find the best value. Okay. So we need to give a range. That's how it works. You got it? Because if we don't give it a range, it will not know where to test, what to test. But if we ask it, okay, test between this to this, then it will be fast. You got it? It will be fast. We'll do some more support learning and let's. Yeah, yeah, yeah. You can like I will recommend review this lecture, go through the slides. Sorry, go through the um this notebook and then ask your questions. I believe you will be able to grab it. So this is the first time you are learning everything, right? So maybe it's becoming too much for you. You know all the things. Just give it a read. I hope it will be clear. Okay, guys, I will launch the poll. Hey, you guys need more examples, but we are giving more examples. Like here, what we are just learning concepts, right? We cannot give more examples while learning concepts. This is just a concept, right? We will get examples when we actually do it, like when we actually do it in practice. Okay. Um, Guys, 28 folks are there. Please respond to the poll. Okay, guys. Thanks for your vote. Looks good. I'll end the poll, share the results, and also start the timer. Okay. You guys can have your dinner. Okay, guys, let's start. Yes, everyone is back. Please give a quick confirmation. Cool. Let me do a double check. LBC instructor slide 4.1, 2, and 3. That all we have it here. Okay, so let's go through classification. Yeah, guys, apart from regression, classification is also a supervised machine learning technique where the model is trained to predict the class level of given input data. So here the data set is like the target. Before we go to the next, can we do knowledge check PDF? I have three questions, two of them unable to recall. Oh, yes, 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 yes. Who is this? Thanks, Vijay. Let's do knowledge check. Hmm. It only very well. This is not the one. Oh, hold on. Hmm. Guys, let's try to answer this. What is VIF? Are you able to recall? Guys, anyone? Hmm. Vertical inverted file. No, no, no. It's variance inflation factor. Okay, I guess I did not like it was not part of it. So, anyways, variance inflation factor is nothing but it is a measure of multicollinearity in regression analysis. Okay, so it's actually VIF. The formula says like this: VIF VIF equals to 1 divided by 1 minus R squared, or what is this R squared? Okay, so it is nothing but measure of multicollinearity in regression analysis. It quantifies how much the variance of a regression coefficient is inflated due to collinearity within our independent variables. So what happens is if there is collinearity within independent variables, then what happens? The variance factor is high, very high. So it gets inflated. So how much it is inflated, we are able to check through this. So here, what will be the answer, guys? We did not cover this. That's why it was not part of it. See, obviously, data science is so huge, we cannot cover everything. Hmm. Answer we will discuss. Don't worry on that. But what are you saying? Mm, yes, in mind says no. It's always between independent variables that we just discussed, right? So its answer is B. Okay. Why mine says A? Here it's written in A, it's written dependent and independent. But I already told you, right? That if there is multicollinearity between independent variables, then it measures the quantity, how much the multicollinearity is. And more the multicollinearity, more will be the inflation in variance. Okay. Next, y is a sigmoid function. Leave it for now. Don't use it. Don't answer it. We will study logistic regression in classification, and then we will get to this. Okay. But yeah, those who want to answer, they can. What will be the answer here? Anyone? Does anyone know? Anyone? Nice. Nice. Nice thing. How it is happening, why it is happening, don't ask me right now. Let me explain classification then. Okay. This one, I hope you can answer, guys. Perfect, guys. Okay. Nice. Let's proceed to classification. So here, from the such quick random question sets really improve interest and our understanding. Also help us keep away. We are saying, yeah, Vijay, yeah. So if you get questions that is already discussed, so it's very easy, right? But yeah, some other questions, uncommon questions, like it really tests the knowledge. Okay. So here, what do you see, guys? There are two. Can you tell other technique in the last question? Which technique? Which technique? What was the last question? Tell me, what do you want to know? Which technique? Ridge regression and lasso regression. Lasso. In lasso, we the process is to get the coefficient equal to zero, to get some coefficient or most of the coefficient equals to zero. Whereas in like ridge, we get the coefficients close to zero, but not zero. Okay. Can you take the last question three? Okay. Yes. Tell me now. What is A? A technique to reduce multicollinearity between features in the data set. We just discussed. A technique to reduce multicollinearity between features in the data set. What is the technique? If it is what is Q1? Acha, question one. That is different thing. That is vertical inflection factor. Sorry, that is different thing. Inflation factor. That is different thing. If it is a feature variable, sorry, if it is a categorical variable, how can we reduce multicollinearity? Drop one column, right? Other sense, how can we reduce multicollinearity? If there are three columns which are collinear to each other, reduce like drop two column, right? So that's the technique. One hot encoding, not one shot. Okay. PCA is different thing. That's dimensionality reduction, Sina. Okay. There we basically reduce the complexity of the model. Okay. We will get to that. Okay. Coming back to classification. What is this in the curve that you are able to see, guys? Please comment. Exactly, division of data in cluster. There are two classes, classes A and class A and B. We are just classifying the data. So what is the target variable? Target variable is the class where there are two possible values A and B. That's it. Right. Now, whatever is the data set based on like the independent feature variables, we basically create an algorithm which learns and then helps predict the class or the label of the like the class or the label where it belongs, right? Okay. So application can be in healthcare, finance, marketing, retail, and manufacturing. So it's basically a self-read. You can basically go through it and see what are the different use cases for it, right? Let's not invest much time into it. Now, this is the most important thing, guys. Type of classification. What is binary classification? Guys, please comment. What do you think is binary classification? Exactly. No, no, Saha, what I said is what is binary classification? So binary classification is nothing but where the target variable has only two options. Okay? Exactly, Vagesh. It can be A, B, it can be yes, no, it can be true, false, it can be cricket or football, whatever. It's not that it is only yes or no or false Boolean value. It can be anything, but only two possible values allowed. Now, if you see multi-class classification and multi-level classification, there is a thin line which separates these two. Now, both of these are like from the word, it looks like it's trying to say multi-class. It means and multi-label. It means the target value in the target value there are multiple options. Like let's say a student is studying. One second, guys. Not sure. Suppose a student is studying, right? And it can be we know the class, other we don't know. Can you repeat? Which one? Which one? Binary or multi-class? Saha? Saha, which one you want me to repeat? Multi-class, huh? It's nothing to repeat. I'm still talk- talking about it. Don't worry. Oh, that was previous. Okay. Hold on. Give me a second. Hold on, guys. Okay. So would you like to take a try? What is the difference between multi-class and multi-label? So multi-class simply multi means multiple options, not just two options are there, right? There can be multiple options. What are they? Let's say a student is in school. It can be he can be in any class from a class, let's say 1 to 10 or 1 to 12, right? Many unknown classes or many known classes also, not unknown. Obviously, all of them are known. Why unknown? Acha, that way you are labeling. Okay. Multi-class is many unknown classes and multi-label is multi-class known. Mm. Okay, so I will give you the opportunity to elaborate this a bit. Yes, yes, definitely. Please try to add some examples so that we can understand. Yeah.
Yeah, so what I tried to meant was like, for example, mm, mm, okay, we have some list of fruits, right? I'm just giving a vague example, but yeah,
Mm.
a list of fruits. The idea is to know when the fruit was ripened, say 10 days back or 4 days back. We don't know, but due to some with some factors, it is able to cluster it into say 10 days, 1 days, 2 days, but we don't know the group in the data whether it was 10 days back or 1 days back. In such case, but the model is able to cluster it. In such case, we call it as multi-class, where we don't know the label. But in case of multi-label, when the data is given only, we know, okay, these are set of apples that was ripened 10 days back, so we can give a 10 days back, and we can like that we can give a label and train it. So it is kind of a little bit known, and this is unknown of
Mm.
what cluster it is, something of that sort. That's what I was trying to say.
Any other participants want to try? Guys? Hey, no. Krishna is sharing a whole screenshot. No, Krishna. That we can, every one of us can do. But let's try to explain it in chat, right? Yes, whatever you mentioned is totally correct. And it is in line to what Saha said, right? Okay, let me give you an example. Better I explain this example only. So let me share apple, orange, banana. Na? Since you pasted this, I will share this example, multi-label and multi-class. So multi-class is single label. Multi-label is multiple label. That's it. Okay. Now, since it is single label, so only one value possible in the given set of classes. Okay. In multi-label, possibility of occurrence of multiple labels is there. Okay. How? Let's say my task is to classify a fruit as apple, banana, or orange. Okay. So here, what are the possible outcomes? The possible outcomes are the fruit can either be apple or banana or orange. In each of these cases, only a single value can be possible in, like, once in one case only one value is possible, or uh, right. Now I'll give another example. Now I will give another example, another task. So here what happened, The task was to classify a fruit as apple, banana, or orange. So a fruit can either be apple or banana or orange, right? Not all at the same time. But a task, if I want to say, detect objects in an image. Okay. So if it's an image and there are multiple objects present, so it can either be like this: apple, banana, and orange all present together. So here a chance exists that multiple labels can coexist together. What are the multiple labels? Apple, banana, and orange exists together. No, not one item can belong to multiple sets. No. In that particular one item, the classes that we are describing, right, it can exist in all classes. For example, here if you see, it was either one for apple, it was zero for others. For in case of banana, it was one for banana, zero for others. So what are the possible outcomes here? The possible outcome is image contains all three. So 1, 1, comma 1, all three. The image consists of apple, banana, and orange together. So all three are one, right? Image contains, let's say, banana only. So if it is banana only, then 0, comma 1, comma 0, like this, right? If it contains, let's say for an example, apple and orange, then it will be like apple and orange. Then it will be like 1, 0, 1, like this, right? And it keeps going. So a chance exists that when we choose an object, it can exist in multiple classes simultaneously. So that multi-label, multiple, it can have multiple labels simultaneously. So that like at a time only one level, that's multi-class. Guys, you got the difference? Everyone, just say yes or no. And what is imbalanced classification then? Guys, what is imbalanced classification? Any idea? Any idea, guys? What is imbalanced classification? Guys, you can. No, not more items in one bucket. Simple case. Acha. Any other examples? Classifying imbalanced data set. Yeah, classification not possible. No, no. Like anomaly detection, simple. Let's say bank fraud cases, right? So here you can say that it's a binary classification or binary classification that either credit card transaction is fraud or not fraud, right? But it's actually, although it's binary, but it's actually unbalanced because let's say what happens is that's the trend is if 10,000 transactions happens, 9,999 transactions will be non-fraudulent. Only one transactions will be fraudulent, right? So here an inconsistency in the number of occurrences of target value is there, right? That's the reason we call it imbalanced. Simple. Bias towards one class. Yes. Okay. Some of the popular used binary classification are logistic regression, naive Bayes, k nearest neighbor, decision trees, and support vector machine. One thing I would like to tell you, these algorithms that I mentioned uh, are specialized for classification, but they can also be used for regression. It's not that you cannot apply regression on them, but yeah, they are like specialized in classification. Let us discuss about logistic regression. Uh, so instead of discussing much about logistic regression, let me directly show you. One second. Huh? I hope you are able to see my screen. Adding non-linearity. Guys, this is a curve for linear regression, you remember? Where the value was y equals to mx plus c. So this curve represents y equals to mx plus c. Now, now adding log both sides, then what it will happen? Log of y equals to log of mx plus c. So it gives a final equation where the curve looks like this. If this is x and this is y, the curve looks like this. So here, if you see in y, especially there are two values. If you remove this particular value of x, where it is transitioning, right? Where it is transitioning, we can consider two values specifically, y equals to 0 and y equals to 1. Okay. So that's the reason the logistic curve, this curve is known as logistic curve, because this is achieved by performing logarithmic operations on a straight line equation. So that's why it's called logistic regression. Now, you see this behavior that it is 0. The target value y is 0 for a particular value in X, and suddenly it reaches Y. So what happens is, if we keep a threshold at this point, we can very easily distinguish between a binary class that is having two classes, right? A binary variable that is having two classes in the target value, we can very easily distinguish it if we use this logistic regression curve, where one of the classes would be linked with 0, another class would be linked with 1. Okay. Oh, sorry. I did not stop this here. So what happens is, let's not go there. Cost function, loss function, let's not go there. It will be a lot for you guys. What you guys need to understand is the curve that I showed you. That's it. Uh, if you understand that, it will be enough. Now, let us try to explore this logistic regression with a breast cancer dataset. So as the dataset suggests, can we simply say it makes the prediction to be in the range 0 to 1? Yes. Yes. Now, what happens is, till a certain probability is achieved, let's say 50% probability, right? It predicts it as 0, right? Once the probability for one, like for probability for one, or say probability for true, right? The probability increases 50% and above, then it predicts as 1, right? So it's not a range from 0 to 1, it's either 0 or 1. So here we have a data set where it consists of 569 instances. It means 569 rows. Okay. Number of attributes, or number of parameters, or number of feature variables are 30. These are computed from digitized images of the tissue samples. Okay. So these are all breast cancer data set. What are the attribute? The radius of the tumor, the texture of the tumor, perimeter, area, smoothness, compactness, and so on. A lot of things, right? So what we are going to do is, here we are going to implement logistic regression on the variables on the data set, and then finally predict if the particular patient with the symptoms is having a breast cancer or not. Okay, this is what we are going to achieve. What we are doing here, importing all the libraries, then reading the breast cancer dataset from the breast cancer dataset using read.csv. Let me connect and then upload the dataset as well real quick. Yeah, connected. Now let me go ahead and upload all the datasets for this. Dataset application. Let me download all. Open. Okay, all downloaded. Let us implement. Sorry, execute this import statement, and then execute the read CSV thing. How to decide which algorithm? Why logistic? Why not KNN? Ashutosh, do you know what is KNN? Do you know what is logistic? Do you know what is support vector machine? Right now, as of now, we don't know, right? So we are learning it. And once we learn it, we will be able to decide which one to use. Obviously, each uh, depending upon the use case, we will have the, depending upon the use case and the data set, we'll be able to select it. So first, let's learn the algorithm, and then we will be able to distinguish which algorithm to we use when. Okay. But can we use all these in? Yes, you can use any of these in classification. Now, which algorithm is going to fit better? We don't know. No one knows. You have to use all and then see which one is giving better results, and then you proceed with that. Okay. Now, what the info says? There are 569 rows. Only this unnamed is blank. If I see all everything is fine. Okay. So let us do df.describe. If you wish, you can go ahead and see the descriptive statistics. What is the skewness and all, right? We are checking df is null sum. So that is something that you already know. We will remove this unnamed column. Huh? It means nothing. This one you will like. What we are doing here is we are doing basically a bar plot or a histogram type thing, right? To find the kind of diagnosis. So if a tumor is benign or malignant, guys, benign tumor means non-cancerous and malignant tumor means cancerous. Okay. Now, how we do it? I will open this code. Anyone would like to like you guys look through it and say if you understood it or not. Let me know if you still have some confusion here. I will help you understand. Guys, go through this line, 5 lines of code, and let me know what do you feel about it. You understand? Guys, anyone would like to try? No one is saying anything. Hey, it's very easy now. What we are doing here is, let's see. We are doing a count plot on the x-axis. The column diagnosis is there, and the data is the data frame. The title is so for x-axis the diagnosis there are two values, benign and malignant, right? And that's it. And here we have created a separate ticks 0 and 1. So the value that you are able to see benign and malignant is something that is for if the answer sorry if the diagnosis is 0, mark it as benign, and if the diagnosis is 1, mark it as malignant. So this mapping we are doing. Okay, so in the data set the diagnosis is marked as 0 and 1, and here in xticks we did the mapping and plotted it. That's it, right? So simple, right? Then what is the value count? If we are doing diagnosis, that value count, if you see, benign is 357 and malignant is how much? How much, guys? Now, this column unnamed, we will remove it simply. So that we are doing here, right? And after that, we do a heat map. Heat map to check the correlation. Now, what I will do is I will reduce the size for you guys to so that we can see the heat map in one single sheet. So here, the lighter the value, greater the correlation. That's it. What is 212? 212. Acha, I guess that was malignant and benign count. Yeah. So guys, you are seeing, can you tell me why this diagonal value? You see, diagonal value is all one. Why is the case? Because it is the correlation, it is self correlation, right? For example, the correlation of area mean with area mean itself. And apart from that, which are the other columns you see there is correlation? For example, I can see there is correlation between radius mean and uh, so so I can see there is correlation between radius mean and radius post. I can see correlation between perimeter mean and radius post and so on, right? So what do you see? What is the high observation? Here, observation is high correlation. Several pair of features exhibit strong positive. How is the benign and malignant count done? Okay, Nisha, let me show you. Here, this one you were saying, na? So if you see stage 0 or benign count plot X diagnostic, benign and malignant. Let me show you the value first. Okay, benign is actually 357, so it's opposite. It will be opposite. Thanks for making that call. Okay, control X, comma, control V. So nothing. We do a count plot here. See, diagnosis value count. What do you see? We see benign as 357 and malignant as 212. So see, malignant as 212 and benign as 357, right? So that's how the count is done. Okay, Nisha? Guys, why plotting? Oh, why plotting? Okay, let me show you. So if you see, here we have, wait, X sticks I will remove. Just this one I will remove and re-trigger this. See, what are you seeing? You are seeing M and B by default, right? Here, it's the count plot. What we are doing, we are saying X equals to diagnosis. So on the X axis, we will have the diagnosis column values. There are two values only in diagnosis column, malignant and benign. Okay. So we are doing a count plot for the same, and then that plotting that count plot in the chart. That's it. Got it? So the count is, if you see the count, malignant is 212 and benign has 357 that you can see here. We are just doing this SNS, Seaborn dot count plot, and we are showing it. So count plot is itself a plot like this. Got it? Got it, Nisha? Now, now, what is the observation here? Guys, high correlation is present, feature groups and clinical relevance. In high correlation, several pairs of feature exhibit high positive correlation. Fair enough. For example, radius mean, perimeter mean, and area mean are highly correlated with each other, right? This is expected as as these are all measures of size and dimensions of the detected tumor. Okay. Feature groups, features related to the largest value of these features related to the ORST mean and error calculations are grouped together, indicating that similar types of measurements are highly correlated. For example, radius ORST, perimeter ORST, and area ORST also show very high positive correlation, right? So these are groups. So wherever there is ORST, all the ORST values are showing high correlation. For example, if the radius ORST is low, obviously perimeter would be low and area would also be low. है ना? And what is the clinical relevance? High correlations between features like concavity mean and concave points mean suggest that more concave portions of the tumor outline correspond to more frequent concave points, which are relevant characteristics for diagnosing malignancy of the sample. So more there are concave portions, what is it? Concavity mean and concavity points mean, right? So more the concave portions of the tumor, it outlines more frequent concave points, right? So guys, you understand the difference between convex and concave, everyone? I will show you. Better I show you. No? Difference between concave and convex. You know? Yes or no? Hmm. Tell me which one is what. Which one is what? One and two. Which one is what? Okay. One concave, two concave. No. See, concave is one, and this is convex. Now, how to understand which one is concave? See, cave means an inward structure like this, right? Inside this, like a cave is there. So here it is inward. It is concave. Okay, cave. It is inward curvature, and this is convex, which is having an outward curvature. That's it. Okay, everyone. So in a tumor, uh, suppose there is a tumor. So in this tumor, more concave portions means more concave points, and more concave points mean it is malignant tumor. Okay, got it? So this is the clinical relevance of concave points. Okay. Now, what we are doing here, guys? First of all, we are using label encoder to convert the diagnosis value. So what will we do? Let's say we will, for an example, in label encoder, what we do? For multiple values, we assign multiple numeric numbers. Okay. So what are the values? Let's say we assign for benign, we assign 0, and for malignant, we assign 1, like this, right? So this is label encoding. So if you see encoder.fit transform, day of diagnosis, the value from B and M changes to 0 and 1 respectively. And now what we do is, mm, what we do is we take the X by dropping the target value, that is diagnosis, and we take the Y with diagnosis only, and then perform the train test split, right? Now, what we are doing here, guys, please see. If you remember, I skipped one thing, the pipeline, right? In the last slide, if you remember, I skipped one thing, pipeline. I will tell about it now. Random state. Random state is nothing. You choose anything between 0 to 100, nothing. Random state 0 means the values will be chosen at like 0 randomness. It means it will be serial. And random state 100 means the degree of randomness will increase. That's it. Okay. So basically pipeline is nothing but a series of steps that we perform before implementing a machine learning model. So here, what is like here, for example, we are taking into account two things. One, we are performing scalar using standard scalar, and then implementing the logistic regression with maximum iteration 10,000, random state, whatever you want to take. And then instead of using logistic regression dot fit predict, what we are doing, we are directly using the pipeline dot fit predict, and we can do that. Why? Because if we are using the pipeline, first it is converting the data to standard scalar, and then applying the model to train it. Okay, so fit means train. So that's the purpose of pipeline. Your redundancy decreases. You do not need to implement multiple line of codes. So it basically decreases. Is it to reduce the line of code? Yeah, exactly. Then what we do? See, using the train data, we do a predict, and using a tested data, we do a predict. And the great thing, like the main thing you want to see here is the pipeline dot predict probability. You remember I was talking about this, that for each row or each data point, there is a prediction probability. Pipeline used to execute in sequential manner. No, not sequential manner. One thing is sequential manner, that first standard scalar will happen, then algorithm will work. So that thing though you could have executed in number of lines of code also. But if you are writing pipeline, then what will happen? Just in pipeline, you just write fit and predict, and all the actions will take place simultaneously. You do not need to write like multiple lines of code. So sequential manner is true, but sequential manner we can also obtain by writing the same thing in multiple lines of code. Okay. Okay. Now, what is predict probability? Guys, you remember I said that for every data point is using sigmoid curve. No, it's not. It's not. I will tell you. Let me try to explain it verbally. If you understand, good. If not, I will use the iPad. Okay. For every data point, it has a probability for one. So let's say for data point one, the probability that it is one, like either zero or one, right? So the probability that it is one is, let's say, 10%. So if it is 10%, then like the probability that the answer will be one is 10%. So what will be my answer? It will be zero, right? Because the probability is less than 50. Similarly, the probability for data point two, let's say the probability that it will be one is 60%. So in that case, what will be the actual answer, guys? What will be the actual answer one? So for each data point in logistic regression, we have probability. And for any data point where the probability exceeds 50%, the answer is one. And for the data point where probability is less than 50%, the answer is zero. Now, if we run this, we will get a lot of things like this. See, actual level, predicted probability. So predicted probability here is 0.11. What does it mean? Guys, what does it mean? It means, does it mean that probability that it will be zero is 11% or what? Can you comment? What does it mean? The probability that it is one is 11%. It means it's less than, that's why it's zero. It's less than 50 and that's why it's zero. So rest, everything you understood? Clear? Very clear, guys? How logistic regression works? Is it clear? That's the only one thumb rule that you need to know. That for in case of a binary class, not only binary classification, in case of a multi-class classification also, each class will have a probability. Like in binary classification, one class will have probability. In multi-class, all the classes will have probability, and whichever increases the threshold will get the final ultimate one. which on approximation gives the sigmoid. We can say so. Maybe it is like this predicted probability is the real value the model gives, which on approximation gives the sigmoid. Yes. So this sigmoid curve is not for all the values combined together. This curve is for each data point. Okay. For each data point, the probability will lie somewhere on the sigmoid curve. And wherever it lies, if it is above the threshold, it will be triggered as one, identified as one. If it is present below the threshold, it will be identified as zero. Okay. Now, what are we doing here? Training accuracy. We are seeing accuracy score and all. Now, this is what I will teach now. Model evaluation for classification. My best topic. This is the one that I love the most. Mm, this one that I want to teach you. True, positive, true, negative, confusion, metrics, accuracy, precision, recall, F1 score, and all these. Okay. ROC, UC curve, area under the curve. Yeah. So let me do this. ROC, UC, false positive rate, and true positive rate. Okay. We will do it today. Guys, let me get a 5 minutes breather, get some water, come back, and we will do what? We will do today model evaluation for classification models. Okay. I'm not putting any timer. We'll be back in 5 minutes. Let's be back at 20 to 22. Okay. 20 to 22 is the time.
Hi, sir. Hello, sir. Sorry to interrupt you. Actually, you're on mute.
Yep. Sorry. Thank you, guys. So whenever I'm on the notepad, I don't see over the chat. Thanks for letting me know. Okay. Okay. So guys, consider this particular four block 2D plane. Okay. I'm audible, right, guys? Hmm. Consider this 2D plane where we have four blocks. On the left hand side, let's say actual value is 0 and 1. Okay. So 0 represents this particular row, the upper row, 1 represents the lower row. Similarly, predicted value, like actually 0 and 1, a machine learning model predicts a value. So the predicted value, the left column represents 0 and the right column represents 1 in the predicted column. Okay. Now, for the left column, the predicted value as 0, what is it predicted as? This is predicted as negative. Yes. So I can simply go ahead and write negative in the left column. Okay. Similarly, if the predicted value 1, it's predicted positive. So I write positive in the right column. Okay. So prediction in the left column is positive and prediction in the left column is negative. Till this is fine. Everyone understood? Yes or no? Till this point, everyone understood? This is actual, this is predicted, right? On the left side, actual, and on the top, it's predicted. So on the left side, if you are seeing the top row represents a 0 actual value, and on the lower row, it represents 1 actual value. Similarly, on the left column, it's 0, and on the right column, it's 1, right? Now, on the left column, the predicted is 0. So we can simply say that the prediction is negative, and on the right column, as it's 1, the prediction is positive. Okay? Till now, it's clear? Till this point, is it clear? Krishna? Krishna, is it clear or you want me to repeat again? Okay. Now, tell me, how was this predicted? The prediction was true or false? It was 0 actual value and predicted 0. So prediction was true or false, guys? So it is called as this case where actual value is 0 and it is predicted as 0. This case is known as true negative. Similarly, the case where actual value is 0, but the prediction is positive. Actual value is 0, but the prediction is 1. This case is known as, so this prediction is actually false. False positive. Here, actual value is 1 and prediction is 1. So this prediction is actually true. So true positive. And here again, actual value is 1, but predicted is 0. So false negative. This is called confusion matrix. Now, I prepared this confusion matrix in such a way that I hope you will never forget this. Right, guys? Now, this confusion matrix you will remember forever, I hope. Can you confirm on that it's understood fully? Then we will. Perfect. Now, let me just confirm one thing. Precision is true positive by false positive plus true positive, right? Precision, true positive by, okay. Now, what is the accuracy here? Accuracy is equals to total correct prediction by total prediction. So tell me, out of these four, which are correct predictions? Hmm. This one, true negative, true negative and true positive, right? So it becomes true negative plus true positive by true negative plus true positive plus false negative plus false positive, right? So this is accuracy. Accuracy is all correct predictions divided by total predictions. So now there is another term called precision. Anyone would like to tell me what precision is? Total prediction equals total actual. Okay, I will give you a how close we are to accurate value. So I will tell you. You are able to see this right column line. This particular column, this blue one that I highlighted right now, is the line for precision. How to understand? Here you can see predicted P on the top. So this means the precision column. Now, how to find it? Precision is nothing but true positive by true positive plus false positive. It means out of all true, out of all predicted as one, how many are actually one? Right? I did not use any fancy keywords to explain, but precision means if you have predicted 100 values as true, how many are actually true? Right? So precision means whatever you predict correctly. If you can't, don't predict correct. Like don't predict true. Okay, don't predict one. Got it? Out of all predicted as one, how many are actually one? And there is another term called recall. Recall is nothing but again true positive by true positive plus false negative. It means out of all actually one, how many are predicted one? Okay, recall is this red one, where actually it is true, but I want to find how many are predicted true. In precision, all predicted true or one, I want to find how many predicted correctly. Got it? So got this difference between precision and recall? Everyone, yes or no? Kindly recall, repeat. Okay, Shah. You are seeing this particular row, this one, the yellow one that I am highlighting. Sorry, the green one that I am highlighting. You are seeing this row means actual value is one, right? So out of actual value, which is one, how many are predicted as one? Wait a minute. Let me give charge. So out of all the true values, how many were predicted true is recall. Okay. So recall deals with this particular row and precision deals with this particular column. This particular column. Okay. This is precision's column and this is recall's column. Got it, Sahab? You want me to repeat again or you got it? I hope you got it. That's why you wrote the second yes. Okay. Now, What else is remaining? Let me see, huh? I told you. Now recall is also known as sensitivity or true positive rate. Okay, all these we call it in tandem. So these we call it all three. Okay, we cannot see your iPad. Sorry. So recall is also called as sensitivity or true positive rate. Okay, no problem, right? Now another thing, specificity or false positive rate. So what is true positive rate? What is true positive rate? Or recall, this particular row is true positive rate. Similarly, this particular row, false positive is present, right? This is known as false positive rate. Got it? So false positive rate or specificity is false positive by false positive plus true negative. That's it. Equals to false positive by false positive plus true negative. See, false positive by false positive plus true negative. So this row is for false positive rate and this row is for true positive rate. Now true positive rate can also be called as recall or sensitivity. Okay, recall or sensitivity. Got it, guys? Till now, all clear? Uh, Now we have F1 score. F1 score is nothing but I forgot the formula. Let me see the formula. I am writing it in the note, but I'm not showing it to you because you can see from this screen only, right? So it is basically a harmonic mean of precision and recall. F1 score is nothing but harmonic mean of precision and recall. Guys, we will discuss, don't worry, we will discuss which case accuracy is important, give a use case where precision is important, give a use case where recall is important, give a use case where F1 score is important. We will discuss everything. Let us first understand the term. Okay, harmonic mean of precision and recall. So F1 score is nothing but 2 into precision into recall by precision plus recall. That's it, right? Specificity we understood. Now, from the concept point of view, guys, please tell me if you understood all these highlighted points: accuracy, precision, recall, F1 score, and specificity. Everyone. From the, at least from the definition point of view. Now the use case we will understand separately. It's a separate half-an-hour discussion for which we don't have time right now. We'll do it later in the next class. But tell me you understand these concepts or not. Everyone, I want answers from everyone. Okay. Now there is something we need to understand, which is no ROC AOC curve. I will not cover today. Okay. Let's leave it here only. Now we will discuss few scenarios. Okay. Give two scenario, like give a scenario where you think, acha, usually we consider accuracy as a performance matrix, right? Uh, Hmm. So suppose there is an algorithm which we want to find how it is performing, right? So what will we do? We will see if its accuracy is good or not, if its accuracy is 95% or not. Okay. So if accuracy is 95% and above, it's a good model. Okay. So till that point, we all know. Okay. Let me tell you one scenario. Huh? Consider, consider accuracy of 95%. What does it mean? It means out of every 100 records, it predicts 95 records correctly, but there is a chance of error for 5 records. So if there are 1,000 records, there is a chance that it will predict 50 records incorrectly. Yes. Now, suppose in a bank fraud transaction, out of 1,000 records, hardly one record is a fraud one, right? So if we use accuracy as a performance matrix, do you think 95% accuracy will be better for us or good for us? Or even 99.9% accuracy will be good for us? No. Even 99.9% accuracy leaves a scenario where there is a chance of predicting it wrong, right? So what to use there? So there, it is hard to get 100% accuracy, because if you get 100% accuracy, then it becomes overfit. But it is very easy to get 100% precision. Why? I'll show you. So what happens is, in that case, in credit card fraud detection case, what I need is whatever I am predicting, right? It should like consider the total values of fraud transactions were 50. So while predicting, I should get all 50 as true positive. It means I should predict all those 50 transactions as fraudulent transactions. So in that case, what will be my criteria? What will be my criteria? My criteria will be two things. Suppose a credit card fraud occurred. Which is more painful? Like, consider the occurrences and consider the actions. My model predicted fraud. Model predicted non-fraud. Which one is painful, or which one should be reduced to 0? This one is not accepted at all, right? If it is a fraud, it should be caught as a fraud. This one should be 0. You agree? Yes or no? Model predicting it as a non-fraud should be 0. Yes. So if we go here, if actual is 1, it means if it is actually false, sorry, if it is actually fraud, then my model should not predict it as non-fraud. So in that case, what should I minimize? I should minimize the false negative value such that if a fraud occurs, everything is true positive. So what should I minimize? False negative. Now, what is recall? Recall equals to true positive by true positive plus false negative. So if I minimize false negative to 0, recall becomes 1. So in cases where I want to catch even the minute minute cases where, let's say, out of 1,000 only one record occurs, one fraud record occurs, and I need to catch that. So in that case, I need to make recall 0, recall 1. So I need to create a model where recall is 1. Got it? So this is a use case where we need to create a model with recall value as 1. Got it, guys? Yes, obviously. Now, precision. Let me do this, get this clear, else it is becoming machli bazar. It's looking better now. Okay. Now, consider a case of preventive maintenance. Okay, that suppose there is a machine. Now that machine, if it stops functioning suddenly in the industry, then what happens? The production is stopped for a long time. So like we will have to call the technicians, the mechanics, they will come fix the machine. So even if 4 or 5 hours go drained like this, what happens? The production output comes to a hit. So what can we do is we can make sure that we can build an algorithm that whenever the machine is about to get faulty, my algorithm will predict it and I will do preventive maintenance. So whatever it costs me, right? I will do preventive maintenance. Now, in that case, suppose I predicted 10 times. Sorry. Let's say I predicted 10 times that my machine or on 10 occurrences, I predicted my machine is going to get faulty. So I said, or my model said, get preventive maintenance done. So according to this, what will I do? I will ask the mechanics to come and do the maintenance, right? Now, while I am doing the preventive maintenance, this might not take 4 hours. This will still take 30 minutes or 1 hour. Obviously, it will also take some financial expense. So what happens is, consider out of those 10 times, the mechanics came and said out like 5 times they said that machine is okay. It did not need maintenance. So what happens? Without any reason, my machine got stopped for 2.5 hours without any reason, right? It did not needed maintenance. It was all fine. It was working fine. Due to some reason, my algorithm predicted that it needs maintenance. Right? So what should we do? I will again draw this 0, 1 for actual, for prediction 0, 1. So this is true negative, this is false positive, this is true positive, and this is false negative. So here what I'm doing is I am predicting 1. I am predicting 1. But out of the 10 cases I predicted, 5 were true. Actually, 5 were also true. But 5 cases were false positive. It means there was no maintenance required, but actually the machine was all right. But I predicted as maintenance required, machine is going to get faulty. So because of that, I stopped the production. I had to spend a lot of money also without any reason. So what in case of preventive maintenance, my aim is to make sure that whatever I predict 1 should be 1. It should not be false positive. So preventive maintenance cases, the aim is to minimize false positive cases. Okay. So if we minimize false positive cases, then what will happen in precision? True positive by true positive plus false positive, right? So if false positive is minimized to 0, precision becomes 1. So in preventive maintenance cases, what do we use? We use the like in order to configure a model, we use precision to be as equal to 1. And in case of fraud detection or medical diagnosis cases, we use recall as the parameter. Okay. There can be cases we will discuss next class. There can be cases where I need both precision and recall. Then what will you do? Then there is a separate scoring thing called F1 score. Where is that F1 score? F1 score, which combines the good essence of both precision and recall, right? So F1 score, if F1 score is high, model is good. If F1 score is low, model is not good, right? So that includes combination of both precision and recall. Now there is another thing called AUC ROC curve. We will discuss this next class. Now, guys, till now, any questions? You understood all the examples and all? Everyone? It's interesting, right, guys? Why have you gone silent? Clearly understood the example. Example you really get understood clearly. Okay, everyone? Everyone understood, right? Okay. Okay, great. Great. So I had more to cover today, but we are short of time. So model evaluation includes one more concept called AUC ROC curve. I will tell something about it and then we'll cover it in the next class. So what happens is a model can perform differently across different threshold. For example, till now, whatever we understood, the threshold was how much? 50%. Let's say I want a model where it will only predict one. It has one if the threshold is 80%, right? It means until and unless the probability of success is more than 80%, don't predict it one. So in that case, what happens? Model will behave differently, obviously. So for a range of threshold from let's say 0 to 100% threshold, a model behaves differently at each threshold point, right? So AUC, area under the curve receiver operating characteristics, AUC ROC curve is used to measure the performance of the model across various thresholds. That is also we are going to discuss in the next class, okay? And then we'll also do a use case. And finally, we will see how by coding this is done. So in theory, it took us around 1 hour to understand all these things. In coding, it's just one line of code and everything happens, right? But let me tell you guys, model evaluation is one of the most important things in machine learning. Without model evaluation, you don't know if your machine is working good or not, right? So these terms, especially in classification, these terms, precision, recall, specificity, these are very important to understand, right? So I hope you did understand these today. We are done for this day. If you have any questions, please let me know. In the meantime, Anish, can you please share the feedback link? Anish, you're there? Anish, you're there? Let me text her. I texted her. Guys, please wait on her. The feedback link will be provided. Or guys, you can also go to the link. Like I guess you have the link already, right, from the previous sessions, or you can go to the LMS portal directly and rate the sessions. Okay. So if everything was cleared for you, please rate us 5-star. Don't rate it beyond below that. Okay. Yeah. Go. Okay, guys. So yeah, you can go ahead and give the feedback in the LMS portal. And yeah, thanks for your time. Guys, anyone have the link? Please share it. I don't know if LSM is there or not. I have pinged her, but I am not getting any response. You can go ahead. I guess the link is there in LMS portal. Guys, can you check was the link provided, like feedback link provided earlier? No, I don't see it was provided earlier. No, none has. Anish, you are there. Hello, guys, please hold on for a bit. Yeah, thanks, Vijay. Yeah. So guys, we have the link now. Please use the link to provide the feedback. Please rate us 5 stars. I don't want you to rate less than that. Yeah. Okay.
Thank you everyone for your participation. Thank you, sir. Thank you for today's session.
Yeah. Thank you.
I have shared the server link in the chat window, guys. If you felt this session was informative for you, please do consider rating us 5. For anything which is less than 5, please help us out with your comments so that